name's Anna Ten Bensel. Welcome back to my channel. I am again in my little what's her name? Little Red Riding Hood grandma wolf outfit today. Trying to do some new stuff with my hair, so this is how we have to do it. I am going through these LeetCode problems as per usual, and these solutions are in Python. However, my solution is not here, so we're gonna have to go to the submission folder tab. But this is question number 69, and 69 was supposed to be easy. You guys are more than welcome to read this on your own time. I did struggle with this a little bit, just a little bit, not a lot of it, because my runtime was not very good. But this is my solution, but my memory beat 98% of users with Python. So let's go ahead and jump into a simple explanation of this solution. And this solution, you guys are more than welcome to make it better, make it worse, like I usually say at the end of my videos. This one, I would actually love to see what people can do for runtime. I've since thought about it a little bit more, and I think I know how I would want to change it and how I will be changing it in the future. But, yeah, let's jump into it. So I started my solution with a base case. So I said, essentially, if x is less than 2, then the answer is x itself. And let me go over here. Actually, let's copy this over so that you guys can see. Okay. So yeah, that's my base case here, and then for x in the next section, for x greater than or equal to 2, we use a binary search. So this binary search, essentially, we take the left, we initialize the left to 1, or the smallest possible square root, and right to x by 2, which is the largest possible square root. So in this loop, we calculate the middle value, which in this case is mid. And to calculate the square of mid and store it in the square, we check if square is equal to x, and then we return mid. Then we check if square is less than x and update the left to mid plus 1, which then searches the right half. Then down here, we say if square is greater than x, then we update the right to mid minus 1, which it tells them to search, tells our code to search the left half. We continue that binary search loop until the left exceeds the right. And the square root of x is then stored in right, and ergo, which is why we return right. And that's probably the easiest way I can describe this. It just is, to me, was one of the more efficient ways to find that integer square root of a non-negative integer using a binary search. 2020 hindsight, would I have done it the same way? No, but overall, in terms of memory, it was really well. I would have loved to reduce the runtime of this, and like I said, have an idea on how I want to do it, but I'm going to do all these ones that I got less than 50 at least one category at a later date. So keep your eyes out for that video, but I hope that makes sense to you guys. I have, like I mentioned, the code for this in my GitHub repo that's called LeetCode Solutions, which is in the video description down below. You guys are more than welcome to fork and clone, make it better, make it worse, have some fun, learn something new, and I will see you guys in the next video. Thank you guys so much for watching. Goodbye.